give them right back to you so you can study for your test that we'll have tomorrow. The test will be 2 pages, front and back. There's a calculator portion and a non-calculator portion. I did reduce it a little bit from what I've done in the past. Sorry, I'm just glancing at it real quick. Trying to make sure there's nothing that I'm forgetting to go over with you all. Nope, nope. And then calculator portion. No, yep. The only thing that we don't have a ton of practice with, I'll show you in a second. The things I want you to think about. But I'll make sure we talk about it. Actually, I think it's in the review packet that I've given you that we'll work on a little bit today, so before I just give things away. Alright, so we're going to do an analysis of that final demonstrating understanding. We're going to review the test. I would love to take the last 30 minutes to start the next unit. I was telling Mr. Hobby that I actually looked at my lesson plans from last week and the slides that I made, or last year, sorry, for this same class, and we're 3 or 4 days behind and we still didn't get quite as far as I wanted to last year, so I'm probably going to do an abbreviated version of the next unit, but also I do want to start soon because, and this doesn't mean anything to you yet, but we need to study a type of function called logarithms. It's one of the big ideas for polynomial function, or not polynomials, oh my goodness, words are a thing. It's a big idea for Algebra 2 that we have to get to, okay? It's also what's going to give you more practice with your exponential functions if that was something you didn't fully show me proficiency with earlier this year, okay? So we got to get to that. So we're going to do that demonstrating understanding analysis. We're going to do some practice review, and then a lesson called mathematics. All right, so I scored things last night. By the way, sorry, make sure there are no pencils even on our desk. I need a pen or a colored pencil or a marker that is not what you use during this demonstrate your understanding. And we're going to start going over this. Okay? Miles sacrificed himself so that you could sit with him. What a good guy. What a good guy. I will point this out really quickly. If there is anyone, put it in the least messy part. Thank you. If there is anyone who's in the back or that wants to move forward, I do have 2 desks up here that it would probably be easier to see the board from. All right. So I'm building a lot of my discussion today off of what I saw us do yesterday and the feedback I gave. And I apologize if I seem out of it. I was up till 11, maybe a little bit later, working on giving y'all feedback. So if the feedback's not the best, just be aware I was already up till past 11 because we had community group, had to lead that for church, and then this. Number 1, this is a big one that a lot of us missed, and I was not expecting a lot of us to miss. The most common response that I got for number 1, where's my fun purples? There we go. Was that there were 3 x-intercepts. That's the most common response I got. But I need y'all to look at your wording again. For those of y'all that put 3, you said it was 3 what? There's 2 different answers I got. One started with an R, one started with a Z. There were 3 zeros or 3 roots. Is every 0 a different x-intercept? We need to keep that in mind here. Some of us put 2 and put 2 for the wrong reason because we only looked at f of x. And if I look at f of x, how many different roots are there? There's 2. But remember, I asked you to look at g of x. So what would the equation for g of x have been? If you had written this out, this would have been very helpful. Notice that I even told you it was dilated to produce this. So what would the equation of g of x have been in this case?
X plus 5 times x plus 5 times x minus 2.
I know this is not a calculator piece, but I want y'all to see what we would see on a calculator if we did this and connected back to that algebra. How many x-intercepts do you see right there? I see one at 3, and I see one at -5. A lot of us recognize that this is a cubic function, degree 3, so why are there only 2 x-intercepts? There's a double root. Guys, we got to recognize the number of roots is not always the same number of x-intercepts. When I look at this one, I see a double root at x equals, without even the graph, where's my double root? X equals -5. And be careful, the multiplicity is not based on the factors, the multiplicity is based on not the x-intercepts, the roots or zeros. What it most accurately is x equals -5 here, x equals -5 here, x equals 3 here. How many times did I get -5? Twice, so that's x equals -5 with a multiplicity of 2. That's x equals 3 with a multiplicity of, so how many different x-intercepts would we have gotten? We only have 2 x-intercepts. So keep in mind the difference between roots and x-intercepts, because if we repeat our roots, those are not going to be different x-intercepts. So please update that knowledge there, right? Make a note that we have a double root, so that's only going to be 1 x-intercept. Landon.
Can you erase one of the x plus 5s and put a square root behind it?
You mean a square? You can put a square, don't put a square root.
That's what I'm
Yeah. So literally what we have is, if we multiply the same thing, x plus 5 squared times x minus 3, notice if I rewrite it like that, it makes it even more clear that x equals -5 how many times? 2 times, okay? What are your questions about that one? And I will point out, if you said 3 roots and you explained why you said 3 roots, I think you still got a DE for developing evidence of understanding. That's important to recognize that there will be 3 roots, but be careful with the language. The roots tell us x-intercepts, they are connected, but roots and x-intercepts, or at least the number of them, are not the same. I also want to emphasize, because this is going to come up later, I need y'all to clearly recognize here, this is a root. So if I ask for you for a root or for a 0, it needs to say x equals. This is an x-intercept. Notice if I write it as x-intercepts, how many x-intercepts do I have? Just 2. I don't write -5, 0 twice. It's only 2 x-intercepts. Okay? 3 total roots include when I count my multiplicity, but 2 x-intercepts. So again, pay attention to that notation for an x-intercept versus a root for a 0. Looks like everyone's done taking notes on that if they need that information. Okay. Alright, number 2. The biggest thing on number 2 is that most of us actually wrote h of x correctly, but we didn't justify. So like a lot of us wrote x plus 2 times x minus 3 times -2x minus 4, but we did not explain why. Why is that what h of x is equal to?
Please excuse this interruption. Any student going on the UA Vision Day field trip, you need to report to the back of the building to load the buses at this time. Any student going on the UA Vision Day field trip,
Yes, that's not
need
us.
to report to the
I don't think
back
I saw anyone for us.
to load the buses at this time. Thank
So
you.
guys, why is this h of x?
You just put -2x minus 4 again instead of multiply it.
Okay, but where do you see the language multiplication? That's the connection I'm looking for. What up here tells us to multiply? Dilate, right? When we see dilate g of x by this, I know that I need to multiply. You gotta explain where that's coming from. How did you know to multiply? Right? You're making a claim, and if you make a claim that that's what h of x is, I need evidence. Why did you say that? Because we're taking g of x. There's my g of x. and I'm dilating it by negative 2x minus 4. I'm multiplying it. That was it. That's all it was. We gotta justify it. Okay? Now, on part B, I'm not going to spend a ton of time here, but there are a few of us that really need to pay attention to this conversation because I always want to connect it back to just a simple multiplication problem. How many of these numbers can I multiply at a time? I can only multiply two numbers at a time. So how many of these factors can I multiply at a time? Only two. It doesn't matter which two, but we need to recognize like 2 times 3 times 5, that's 6 times 5, which is 30. Or it's 3 times 5, so 2 times 15, which is 30. Or we can do it as 2 times 5, which is 10, times 3, which is 30. It doesn't matter how you do it, you got to recognize you can only multiply two numbers at a time. Right? It's only going to be two at a time. So, quick show of hands, who wants to just do these two first? Okay, I got a lot of us. Who doesn't care? Bet. Alright, so that means that we're going to go with x plus 2 times x minus 3. Again, does it matter? No. Okay. Mr. Hobby, can you make sure it's pointed this way so that we can get this? Alright. Remember, you can only do two at a time because like when we talk about a square, how many dimensions does that square have? It only has two, right? So I'm going to only multiply two of these at a time. And by the way, I do want to point out, Xander, I know you've been distributing without the area model. Can you do that without the area model? 100%, right? If you're comfortable distributing without the area model, you can do that as long as you're clearly showing that you know how to distribute. The area model helps us distribute and stay organized. All right. What should go up here at the top? Say that again, Chrislyn. It don't matter. That's what I want us to recognize. Can I do x plus 2? 100%. I actually might recommend x minus 3. I'll show you why in a second. But let's put x plus 2 up here. And then we're going to put x minus 3. And this is what I want to remind you of. This is why I would probably put x minus 3 up here. So many students, when they distribute here, they distribute a positive 3. But what is that 3 actually? Put your minus or your negative with that 3. That's where a few of us made mistakes. That's a small procedural error that we got to learn from. But if you put x minus 3 up here, can you make that mistake? So, two at a time. Got to learn from that. And then we just distribute. What's x times x? X times 2. And it's positive, so I'm adding. What's negative 3 times x? And then negative 3 times 2. And so now, just those two being multiplied, I'm left with x squared minus x minus 6. But that's only the first two. I still have to multiply that by negative 2x minus 4. I can multiply two at a time. That's it. So make sure that you pay attention to that multiplying of two at a time. And so now, I will say this, it slightly matters the way that you organize this, because one of the directions needs to be longer than the other. Because how many terms are right here? And how many terms are here? And so to make your life easy, and I will say this as well, I think some of us got thrown off by just our writing of the area model. Guys, I'm going to make it as big as I need to make sure it's nice and easy to see everything. If you make it small, you know it's easy to miss. The negatives, right? The smaller you make it, the easier it is to miss negatives. Don't do that to yourself. Okay? X squared minus x minus 6. Negative 2x minus 4. By the way, could I have done the x squared minus x minus 6 this direction? I would have just made this direction longer. Okay? And notice once again, to make sure I don't make a mistake, I put my negative with the 4. That way it's easy to make sure I don't mess up the distribution. How many x's am I multiplying right here in this space? So it's going to be negative 2x cubed. How many x's am I multiplying to get here? So negative times negative is positive, so plus 2x squared. Still almost made a mistake there, so be careful. Negative 2x times negative 6 is positive 12x minus 4x squared plus 4x plus 24. If you're paying attention and being careful, that's what we should have. Are there any of these that I need to talk about and explain how I got those values? Okay. Notice why did I circle those two sets there? Those are like terms, right? I got my quadratic terms. By the way, which of these is my quadratic term? The quadratic terms. The 2x squared and the negative 4x squared. So notice like talking about those individual terms can be really helpful and productive. What would I call these terms, the 12x and the 4x? Linear terms, right? That x to the first, the mx piece, that's linear. What am I going to call this piece? Cubic, and this one? Constant, right? Those are the pieces to be able to accurately talk about these in small groups. Now, a whole lot of us wrote this. Because a lot of us did get this far. And that's pretty darn good. What's the issue with this? I showed all the work to get here. That's good. I need h of x. Guys, is this a function? I mean, as I've written it, is it a function? No. For a function, it needs both inputs and outputs. I got inputs, I got x. It's an expression. Because I kind of have inputs. I've got to have the h of x to make it a function. Please do not miss that. Small detail, but important. Got to have that h of x to make it a function. That's a small procedural error, but I'm going to start counting it as a larger and larger procedural error next unit and the unit after because that's important. All right. C, identify the zeros and the multiplicity of the zeros for the function. At least as far as I had checked yesterday, a whole lot of us made this harder than it has to be. How am I going to find my zeros? Set that function equal to? Yeah. Now what can I do?
0 equals 8 plus 3. Oh, 0 product.
Notice that's a little bit of evidence of understanding. If you didn't show evidence with the zero product property in the past, I would make that note. It's a simple note. I don't get to just magically set x plus 2 equal to 0. I know because I have a product of 0 that at least one of those factors has to equal what? 0. Guys, that is a foundational piece that I asked on the last test. You've got to know this. If the product is 0, at least one factor is 0. So either x plus 2 equals 0 or and I trust you to be able to solve those equations. So I'm going to just jump to what the solutions are. Okay, those are my solutions. Those are my zeros. So I do want to point out, based on the conversation we said earlier, should I write this as negative 2 comma 0? No, those are what? Those are x-intercepts. I want the zeros and I want their multiplicities. I also would not leave it like this. I need to say x equals negative 2 with what multiplicity? 2. Doesn't x equal negative 2 twice? Notice I didn't have the same factor, and I did that intentionally because it's not about the factors, it's about the what? Zeros, or the roots. Be careful with that language, because your answers can be wrong, but the zeros, the roots, those are never wrong. So, make a note to yourself, the multiplicity is all about repeated what? That's multiplication. I'm talking about the multiplicities here. Sorry, I should make that more clear. Multiplicities are all about repeated roots or zeros. It's how many times that 0 shows up. The multiplicity is how many times that 0 shows up. Be careful about that. But how many roots am I supposed to have? Supposed to have 3 because this function is cubic. Where's my third? X equals 3 with what multiplicity? Multiplicity of 1. Okay. By the way, that actually goes ahead and answers E. How does h of x above demonstrate the fundamental theorem of algebra? What degree is this? This third degree polynomial has what? Three roots. Now we need to be intentional about saying this. When what? Because it only has 2 different roots, but it has 3 roots when counting the what? When counting multiplicity. So it is about the zeros, but we have to include that note about the multiplicities. There's only 2 different zeros, but there are 3 zeros when we count our multiplicities. So the fundamental theorem of algebra tells us the number of zeros matches the number of roots or complex roots when including multiplicity. Can I erase part C up here? Just trying to prep for the next piece. Okay. Next. Graphing. So I get why a few of us did this, but the first thing I'm about to show, don't write this down. Okay. Some of us accurately graphed y equals x plus 2 as a 0 of -2, y-intercept of 2. By the way, you know I have rulers in the back if you want them to help you draw lines, right? They're, I think, hidden behind those textbooks. Maybe. I'll find it before the test. And then x minus 3, so a 0 of 3, y-intercept of -3, but I want to point this out to you. So what's a negative times a negative? So you mean like all of these positives right here? Something like that. Looking in between these zeros, what's a positive times a negative? So you mean like all these negatives? And what's a positive times a positive? Some of you made your life harder than you had to. I already graphed g of x for you. So if you tried to graph those lines, make a note to yourself like, I already gave you g of x this time. I already gave you g of x. You didn't have to do anything with g of x. All you had to do, because remember that's my starting point. Notice I put g of x right there. What was I doing to g of x though? I was dilating. So I just needed a graph of g of x in there. And there's a couple of different things. One, I had y'all do part C to make your life easy. What were my zeros for part C? It was -2, it was +3, and then, so guys, your dilating factor had a 0 of -2. That's kind of important. What's your y-intercept? Ooh, we need to remember mx plus b, there's my y-intercept. What's that -2 right here? The slope. So that means down to and to the right one. Down to the right one. Down to the right one. And so you didn't have to do all of this. Or up to the left one. You didn't have to do all those points. How many points do you need for a line? Just 2. So if you have your 0 and you have your y-intercept, you're good. That's all I had to do. Okay? So keep in mind that dilating factor in there. Make sure you have that graph right. Then I marked my zeros. You don't have to, but man, I tell you what, it's really helpful. That's what I would do every time, mark those zeros. It just helps me see my spaces. And here, what's a positive times a positive? Hey, what? Positive. I want to point this out. I've seen some people start to kind of do this where we curve, but remember, what we're doing is we're literally multiplying the what? Starts with an O.
Origin.
The origin?
What?
The what? The outputs. Don't forget. We're multiplying the outputs. Remember, the origin's here, and I don't even have a point there. Multiplying the outputs. Guys, if I take a positive 2 and I multiply it by a positive 6, what's 2 times 6? 12. When we dilate, I'm not stressing a ton. I just want to point out, like, realistically, I'm multiplying those y values. So this needs to be steeper than either of the two factors. Just noticing it needs to be steeper. And then we get to right here. And so, again, noting positive times positive. Notice when I take a negative times a negative, what do I get? I also get a... How in the world does it go from being positive to being positive? How does that happen? Say it again. Don't forget, it's bouncing here. So it touches and then goes away. I'm not going to cross the x-axis. I'm going to touch and it's going to bounce away. Notice how many times does it touch the x-axis? Right here. It only touches it once. It just bounces. So for those of us who are struggling with how does this happen, remember, what kind of root is this? It's a double root. Remember, if it's a double root, it's going to bounce. In fact, if it's an even root period, it's going to bounce. So it bounces because this is a double root. But we know it's bounced, it's gone back into the positives, but it's got to get back to that 0, right? And so it's got to turn around somewhere, it's got to have that maximum. And now when I look to the right, don't forget, how many factors do we have all the way through? Because I had one student ask me this, and I just want us to pay attention and remember, how many factors do I have that I'm multiplying? 2. At least on that graph, I've got 2 factors, the quadratic and the linear. So how many do I need to look at over here? It's really easy to get distracted just by this one and forget that this continues. But that's a positive times a negative, which is a... And so it's going to get real steep here. So it has a single root, it goes straight through it. If it has a double root, it's going to bounce. That's the shape of that graph. What questions do you have about sketching this graph? Davis, you awake back there? You know we got a test tomorrow, right? Trying to help you update your understanding before that test? Okay. Kelly, does that make sense now? You with that? All right, moving on. Backside. Okay. So, with this one, I had one student do something phenomenal that is exactly what I would recommend. What I literally ask is for 2 different zeros with a multiplicity of 3. Now, this requires remembering what a multiplicity is. Multiplicity is what? Someone mumbled something. What is multiplicity? So, how many times that root is what? Repeated. It's not the degree, it's how many times that root is repeated. So, what is the root here? I made these nice and easy for you, but what's my root? X equals 1 with what multiplicity? 2. Well, and then this is x equals 3. Do I have 2 different roots that each have a multiplicity of 3? Definitely not. A whole bunch of us picked b, which b is close, but what's this root? X equals a positive 1. And I have another x equals 1 here, so x equals 1 with what multiplicity? 2. X equals what here? And because it's cubed, it's a multiplicity of, and then this is x equals -3. With what multiplicity? So, those are all my roots. Do I have two different roots with a multiplicity of 3? I have one with a multiplicity of 2, I have one with a multiplicity of 3, and I have one with a multiplicity of 1. So I will point this out. If you picked B, there's some evidence of understanding. You could definitely have given me more. But if you picked B, what is the degree of that function? A whole bunch of us said 5, and some of us said 3. And I will point this out. There's a factor, right, with a power of 3, but is this in standard form? Remember, standard form is when I look at the highest power. How many zeros does this joker have? Not 5.
We got 4 this one.
Not 4.
Wait, no.
B right here, how many zeros? It's got 6. Remember, we got to count our multiplicities. So, if there are 6 roots there, what degree is this? This would be 6th degree. If you pick that answer. That is not the overall correct answer. But I will say this, you could have gotten number 4 completely right if you picked B, if you picked the right answer there or identify it, right? 6th degree because there are what? 6 roots. So 6th degree because there are 6 roots, and that's connected to the fundamental theorem of algebra. Guys, and I will point this out. The fundamental theorem of algebra is not degree. The fundamental theorem of algebra connects the degree to the number of roots. Fundamental theorem of algebra just connects the degree to the number of roots. Okay? I bring that up because of number 5. Alright, so we only got 2 answers left. Which one is it? It's which one?
C.
Okay, let's look at D really quickly. X equals what for this one? 2 with a multiplicity of 3. But x equals -2 with a multiplicity of... So do I have 2 different roots with a multiplicity of 3? So I'm not going with D. By the way, I do want to point this out. At least, does anyone know what degree that the function had to be at least if I want 2 different zeros with a multiplicity of 3? It had to at least be 6th degree. Right? That's 6 zeros. It's got to be at least a 6th degree joker. I don't know why I stopped saying joker. Alright, right here, x equals what for my zeros? 5. With what multiplicity?
3.
Okay. Right here, x equals with a multiplicity of, look again, that x minus 3 is here. Oh wait, how many x minus 3s do I have here? So how many times does x actually equal 3? Oh, there's 2 different zeros with a multiplicity of 3. And then this is x equals -3 with a multiplicity of 1. X equals 3, 3 times. X equals 5, 3 times. There's my 7th degree polynomial. Well, sorry, that's my answer. I just gave number 4 away. How many zeros does number 3 have? The correct answer? 7. Right? So 7th degree because why? So notice again, I've made a claim. Guys, when you make a claim, you then need to provide what? Evidence for that claim. Why is it 7th degree? Because there are 7 roots. What's connecting those 2 ideas? What's another detail I could add in? Fundamental theorem of algebra. Okay. So we'll not get to mathematics today. We need to finish this demonstrating understanding up in the next 10 minutes, and then we'll get practice in. Just looking at our time. So 7th degree because there are 7 roots, the fundamental theorem of algebra. What are your questions before I go to number 5? Okay, number 5. Y'all, you made your life harder on number 5A than you had to. I will point this out. Remember, what form is number 5 in? So when I have standard form, I do just look at what? The highest power, okay? So what degree is number 5? 4th degree. Now, is it always the first term? No. It's just the highest what? Highest power. I'm done. You should not be talking about the fundamental theorem of algebra here. Anyone know why? Peyton, did I give you... Why didn't you ask for it, girl? Mr. Cooney, I'm just going to sit here and do nothing. Killing me. Here you go. Thanks for telling me you needed it. Hey guys, why do I not need the fundamental theorem of algebra in number 5? Say again? Because I'm not trying to find what? The number of roots. Guys, the fundamental theorem of algebra connects the degree to the number of roots. Did I ask about the number of roots? I only asked about the degree. Now, in number 4, I did have to talk about the fundamental theorem of algebra because I didn't have the degree, I just had the number of roots. So I had to say, hey, it's 7th degree because there are 7 roots. Here though, can I see the highest power? I didn't ask about the roots here. You're making your life harder than it has to be. We good with this? If I ask in standard form about the degree, you just have to identify the highest power. You don't need to tell me the number of roots, the number of zeros. I didn't ask for it. Don't make your life harder than it has to be. Now for B, the domain and range. By the way, what do we have to be able to look at to get domain and range? Calculators. I need everybody to type this function into their calculator if we did not already. Okay? So, there's the equation typed out. We're going to talk about what scale we should probably use. And I'll go ahead and tell you, on your test, I decided to be nice to you and tell you what domain, or what x and what y I would use. Okay? So, x to the 4th plus 3x cubed minus 3x squared minus 11x minus 6. So for the sake of time on your test, I went ahead and told you what window I would use. So, see, someone's still typing. Got this. Sorry, I'm just talking to myself about time. Alright, so when I look at this, do I need to go any further left with my window? No. In fact, I might get rid of some of this. Notice my last 0 is -3, so I might go to -5 or -6. Do I need any further to the right? No, in fact, I might take out some of this. Do I need to keep going up at all? I'll point this out. It's going to keep going up forever. So I don't need to go up anymore. But down here, you see how I'm missing part of that graph? So what do I need to do? I need to go down with my y. So what button lets me do cool crap? Menu. What am I going to change? Window/zoom. And if at all possible, intentionally change the window settings. Don't just zoom out. Remember, I'm actually going to reduce my x. And so the way I wrote this on your test is I said something like -6, and it's not actually this one. But notice I just did what comes first in interval notation? Minimum, and then, guys, your interval notation is always a minimum to a maximum. So, that's what I wrote on the test. We'll leave the y max alone. Let's go, anyone have a good y minimum that they use? -20 works well. So let's see. Alright, can I see everything now? I mean, not literally everything, because it continues up for forever, right? But can I see all the main pieces, all the extrema in there? Yeah, okay, I'm good. Now, domain and range. Miles did a great thing here that I want to commend. What's the evidence that you provided on the right side after you wrote your domain and range? What'd you explain over there? Maybe I'm not thinking of you. Trying to look. There was some evidence that I really liked from somebody. Tyron had part of it. No. That's part of it. Maybe I'm just losing my mind. It happens. It's not yours. Okay. Is it one of the ones that's over here? Nope. Huh. I have no clue. I could have sworn. Alright, so guys, start with the definitions. What do I mean by domain? And a lot of us switched our domain and range. What do I mean by domain? All the x values, right? All of the, someone said it? Alright, so all x/inputs. And I can see it graphically, right? That's the thing we've been talking about this whole time. I can see it graphically. So when I look at this graph, and I have this arrow going up and this arrow going up, does it ever quit going left? So what's my minimum domain value? Negative infinity. By the way, when I say all x are inputs, remember to think horizontally. So negative infinity to infinity. Oh, sorry, I gave away. Does it ever quit going right? No. So, notice, just a quick note of, hey, that's my minimum x, and that's my maximum x. And don't forget that comma means that it's everything what? In between, right? That's what that comma means, it's everything in between. So, it goes from negative infinity all the way up to positive infinity. Now, range. If domain's all my x are inputs, what's range? All y or outputs. And a whole lot of us assume negative infinity to infinity because that's the majority of what we've seen so far, and that's pretty darn close, except I want you to look at your outputs again. Do you have a y value of negative 20? No. Where does your y stop? So I'm going to trace along here. Tell me when to stop because it has the lowest y value for the entire function. Stop here. A little bit further. So next unit, we're going to talk more heavily about this. This is what we call an absolute minimum because there is nothing lower than it. Well, how do I find out what that value is? Say again, Landon? So I want to do cool crap, right? So I'm going to hit menu, then I'm going to go to analyze graph, then minimum. And so lower bound, remember, I just need to be to the left. Don't go super far left, but I need to be to the left, hit enter, and then go to the right and hit enter. It depends on what you have set in the settings. I'll make sure it's standard tomorrow. But negative 16, negative 16.3, I think, were numbers that we got. I can make this more accurate. Settings, float, 4. So negative 16.31. But so I want you to notice, like my range, what is my minimum y? Negative 16.31, comma, when does the y stop going up? It never does. So infinity. A whole lot of us put a parenthesis on that negative 16.3. But do we actually have that value? Do I actually have this y value? So I need a bracket. So that is a small detail. I think I might have missed one or two because I didn't even notice it at first when I was giving feedback. So if you did not put a bracket on that negative 16.31 or negative 16.3 or negative 16, make sure you put a bracket. Do we actually have that point? Do we have that value? Do we have that point? So do I need a bracket?
Yes.
Remember, when you have that number, you need a bracket. Do not forget, so make sure you go back to the definitions of domain and range. Make sure you remember minimum then maximum. I had a couple of students put infinity to infinity. What's the issue with that? Well, not just that, they did that for range. And I know why they did that for range, because they looked over here at the left-hand side. And then they looked over here at the right-hand side. But if I'm talking about left and right, is that range? And they kind of looked at the y, but notice that that's left and right. And also, aren't those the same? So how's that minimum and maximum? We don't want that. Okay? Make sure you do minimum to maximum. Alright, what was asked next? The relative extrema. Okay, I need y'all to look at this. Looking at it, how many relative extrema do we have? If you did less than 3, that's a problem. If you did more than 3, that's an even bigger problem that we're going to talk about in a second. But, can I erase domain and range? Do we have our notes on this? We need it. Anyone need me to hold on? Going once. Going twice. So, a whole lot of us got extrema, max and min from here. But I need you to go, once again, back to the definitions. When do we have a relative minimum? Stops decreasing and starts increasing. And maybe it's this I was thinking about. Did anybody literally write that language out? Did someone write out stops decreasing, starts increasing? Miles, did you do that? I'm just losing my mind. Alright, so notice what's my function doing right here? It is decreasing. And what's it doing right here? So what's right here? A relative minimum. A minimum is when the function stops decreasing and starts to increase. There's evidence, right? And so I need to find that point. Remember, you can just write the point. But in the most accurate form, what I should write here, once you can see the text, is that it's a relative minimum. What is the relative minimum? And when we say at, or we write the word at, it's at the x value. You don't have to go that many decimals. Probably 1 decimal is fine. But notice it's a relative minimum value, the output, at an x value. And does it stop decreasing and start increasing anywhere else? Yes? Where? Yeah. There's the decrease. Here's the increase. So that's a relative minimum. So a relative minimum of negative 16.31 at x equals 1.147. Again, 1 decimal is probably fine. Final piece, relative max. What's going to happen at a relative max? It stops stops what? Increasing and starts. See, all of this stuff that I'm writing is evidence of understanding. There's my third extremum. And if you've already found your zeros, you can know that. Whoops, I didn't mean to do 0, I meant to do max. So one thing again I want to point out, and I need y'all to notice this. If I start here, is that below that point, or to the left of that maximum? And if I continue here, it gets that maximum, right? But what happens if I continue past that? You see how it starts to get these values over to the right up here? The calculator just literally picks whatever y value is the highest. So if you go too far past your maximum, it's going to pick up higher y values. You've got to go right around the extrema. So a relative max of what? What's the maximum value? So be careful, x doesn't equal 0. So it's a relative maximum value of 0 at, what is the x value? 1. So remember, 0 is not an x, so be careful about that. The maximum value is 0 at x equals 1. Say again. Thank you, -1. I can read numbers, I promise. But I will point that out again, like, it's easy to make mistakes. If you had done a quick sketch of the graph or written this out, would that be evidence of understanding? You could have sketched out a quick graph with the right extrema, things like that. When you had the calculator, that could have been part of your evidence of understanding. It's totally valid. Last piece, I asked you to find your what? Y-intercepts. Actually, just intercepts, I guess, right? So, y-intercept. Hopefully that's easy to see. Where's the y-intercept in this function? Is the what? It's the end of the equation, right? For a y-intercept, my x is what? So if I want a y-intercept, x is 0, that becomes 0, that becomes 0, that becomes 0, that becomes 0. I'm left with -6. Right? That constant. Anything to note why that's your y-intercept. And then how am I going to find my x-intercepts? An output of 0, but I can make my life even easier if I've got a graphing calculator, right? So, hear me clearly on this. There's this thing called the rational root theorem. There's a theorem about how you can find zeros from the standard form. Because I live in the 21st century. If I've got standard form, I'm going to graph that thing instead of having to stress about the rational root theorem. Right? Mr. Hobby, you learned rational root theorem in high school, yeah?
Yeah.
I did too. I was talking with Granberry about it. I was like, how are you going to teach polynomials? Because she's about to start it with her regular class, like I'm about to with my regular class. And she was like, oh, I'm going to do the rational root theorem. And I said, why? And she goes, what do you mean? You got to teach the rational root theorem. I was like, I got a graphing calculator. She's like, oh, you could just see the roots there. Yeah. If you've got a graphing calculator and you got standard form, just find your roots that way. It's easy to find roots in factored form. You set your factors equal to 0. But if you've got standard form, that thing's a pain in the butt. So, I'm going to do cool craps. I'm going to go menu. Now, I don't see x-intercept up here. What do I see? So be careful. Intersection is the intersection of two functions or two graphs in general. It could be a relation in a function. But remember, an x-intercept is also called a 0. To the left, then to the right. To the left, and to the right. Any conversation, any note about, hey, I used the calculator to find my zeros, then I'm good. Now, should I write x equals -3 or should I write -3, 0? What was asked for in that last question? It was asked for what? I asked for intercepts. So should I say x equals -3 or should I say -3, 0? I should say -3, 0. So remember, pay attention to your language. The x-intercepts are -3, 0. They are -1, 0, and 2, 0. And just a quick note of calculator or graph to find zeros, like any kind of note about how you got it. How'd you get it? You made a claim. How do you figure it out? I used my graph to find the zeros. I'm guessing that's what you did if you got it right. But if I have to guess that you did it, have you given me clear evidence? Nah. Now, even still, I took a little bit longer. I want you to get some practice, longer than I meant to. I want to make sure you have some time for practice. One thing I do want to end on is point this out. What degree was this function? It was 4th degree, right? Why do I only have 3 x-intercepts? I got a double root in there. So remember, that's a single root, -3. -1's a double root. 2 is a single root. So how many roots do I still have? Remember the x-intercepts, number of x-intercepts does not have to match the degree, the number of roots does. Okay. Now, we should hopefully have all of these skills down. I want to make sure you have time to practice, so I'm not going to take time to do an analysis of the proficiency scale or have you reflect. I want you to do that tonight, because whatever you can't mark off tonight, that's what you need to study. If you already know how to do the thing, then don't sweat it. Now, here's what I'm going to do. I want you all to self-identify what you want to work on. If you want to work on, so I'm looking at this building polynomials test review. If you want to work on stuff like, I'm going to focus on 2, 3, and 4. So 2, 3, and 4 is all about sketching a function based on the factors, or identifying the type of function, the zeros and their multiplicities. I want you over in this space, right? So 2, 3, and 4 over here. I take that back. Just 3 and 4 over here. Okay. 2 and 5 through 11, you're going to be on this space up here. So this is all about sketching polynomials from factors. Okay. That's here. Over there again is the multiplicities. And if you want the features of the polynomial, and what I mean by that is domain, range. Actually, ignore number 13. That shouldn't be on there because we haven't studied that yet. That's next unit. X-intercepts, Y-intercepts, go over there. So if you want the features, that's 12 through the end. All right. So we'll split into groups once we get to our different regions. So let's get up. Let's go to one of these surfaces or one of these sections of the room. We'll go from there. Yeah. The building.
Last call on notes. What Eric said.
Yes, ma'am.
Last call.
Anyway. Like some different problems. Okay. Some of those you still need to work on. Just glancing at it.
Yeah.